And let's go to the 24. 24. I will read it to you. Pay attention. A mass is true. This is the word. Launch. The project is launched to up. Has in the instant t equals 0. Velocity is 20 in x plus 15 in y. Determine the launch angle with the horizontal and the maximum height. Okay, the maximum altitude, maximum height. So we can use our acknowledgements of math, of trigonometry to do this, okay, to do this. So, for example, we can start this problem and do a graph, draw this problem first. Draw is the most important thing in English. Sorry, in physics. I am a little crazy today. So when the problem starts, we have a diagonal velocity, right? V. But we can think this problem in our y-axis and x-axis, the horizontal and vertical. So here's y, here's x, and here is the x component, and here y component, y, the x. And you can remember, here we have the same vector to do the trigonometry things here, okay? So how can I do this for you? So let's think about the triangle. Why the triangle? Because we want this angle here. Angle is the problem and the first question. What's the angle? How you can see, we have an angle in this triangle. Our body was launched with an angle. So we can do trigonometric things to understand this, because we have the values of the velocity in the axis. For example, in the y-axis, the value is 15 meters per second, sorry. And here we have 20 meters per second. So in this point, you can note we have these components, the sides of the triangle, not the hypotenuse. We have the sides, okay? So we have a trigonometry function to obtain the angle. This trigonometry function, it uses the sides of the triangle. This function uses the sides of the triangle. We have three trigonometric functions: sine, cosine, and tangent. What of these three functions use the sides of the triangle? Do you know? Sine, cosine, or tangent use the sides? Only the sides, not the hypotenuse. Do you know? No? Do you remember the formula, the expression of sine? Do you remember?
Sine theta equal to and
Opposite.
cosine.
No. This is one of the a lot of formulas, but I wanna the formula of sine, cosine, and tangent, only the formula what's only use the triangle, the sides of the triangle. I know we have a lot of formulas to use sine, cosine, but I want the formula only use the sides of the triangle. So, for example, the formula of sine is opposite side over hypotenuse. Do you remember the formula of cosine? Your microphone is a little.
I don't remember it.
You need to remember, man. This is very important. Very, very, very important. Adjacent side over hypotenuse. But we don't have the value of the hypotenuse, just the sides. So we have used the tangent, because tangent is opposite side over adjacent side. Okay? So very important. You need to remember and memorize this.
Yeah.
Oh my God. Ah, okay. So let's remember the angle is here. So the opposite side is the side opposite of the angle. So this is the opposite side. You know the range of the side, size of the side is 15, right? 15. Because it's the same vector. And here we have 20. Here is the adjacent side because it's near to the angle. So adjacent means near. So tangent will be opposite side is 50 over 20. But you need to remember, we don't want to know the tangent. We want to know the angle. But you will use the angle to obtain, sorry, you will use the tangent to obtain the angle. Okay? You need to use the tangent here. So you do this math, you will have 3 over 4. So you need to use your calculator to know what angle you need to put here to obtain this value of tangent. You have this function in your calculator, I am sure, but I don't know what calculator you use, so I will show this in my calculator, but in your is very similar, I suppose. Oh my God. For example, here you can do 3 over 4. And now you can click here in trigonometry and second. So you will have this inverse tangent. You need the inverse tangent because the inverse tangent gives to you the value of the angle, right? So this is what we wanna hear. We want the angle, so you need to use the inverse tangent. So the angle is 36.9 in degree, okay? So you will use the angle in degrees. 36.8, 0.9, I don't know, 0.9. I will around to 37 degree. Okay, so this is the angle, 37 degrees. This is a famous angle. If you remember the last class, I speak to you about the Pythagorean triangle. This triangle, you have 3, 4, and 5 to do the math. So this is a important triangle, a really important. It really the triangle appear in the math a lot of times. It's very common. The Pythagorean triangle show in the math, in the questions. This is the angle of this triangle, this important triangle. So we have the angle, so we have the letter A. Let's go to the letter. This you need to get the maximum height too in the letter A. But you know how to do this. You know. I will speak to you one more time, so you do to me and show to me the math. You can take a photo of your calculator. I will show to you, I will remember you how to do this. The maximal height occur when you have your velocity and y-axis equals 0. So do you remember the equation? V equals v0 plus acceleration times time. This famous equation here. Initial velocity, acceleration time, right? This is the final velocity.
Yeah.
We wanted the final velocity is 0 to get the time to the maximum length. So you have the initial velocity, you have the equation, I show to you. So man, you can do this, take a photo, send me. But don't be afraid about errors, about mistakes, okay? Don't
Okay.
You don't have problem with this with me. You can wrong a lot with me. You cannot wrong in your proof, your tests. Okay, but with me you can be wrong. So do your math, your calculator, and send me a photo.
The velocity will be 0, right?
Sorry, man, I don't listen you. Do you speak something?
Is the velocity 0?
The velocity when you have the maximal height is 0. Exactly. But you wanna know the maximal height. Okay? So you get the time and put this value in the equation of position. And you know the equation of position too. Is that equation with S? Well, I will write here. S equals S0 plus V0t plus 8t squared over 2. You can remember this is 0 because we are in the initial position, in the referential of the problem. The initial velocity, you have 2 because we we read the question. So this value here, okay? And you have the acceleration because you have the gravity. It's minus 10, okay? So you wanna know this, but you will you will use this because it's important. You need the time, okay? You need get the time here to put here, like the another questions you do in the last class, okay? The same thing.
Yeah. So
Okay.
the V0 is going to be 0.
No, zero
Plus,
is the value of the velocity you launch the body. Two up, so is 15. Okay, 15.
50 or 15.
15. This value here, man,
Yeah.
this is the initial velocity. The final is zero because
And A
you
is
wanna know.
negative 10.
Sorry.
A is negative 10.
Yeah, negative 10. Exactly.
Do we also have velocity final?
Again, the final velocity is zero
0. Okay.
because the final velocity is zero because you need the velocity equals zero to the body don't go up more.
Yeah. Okay.
Okay, okay.
I'm done.
Okay. Let me see. So you get the time, 1.5 seconds, and you put this value in the equation of the position. But I suppose you forget the value, the over 2 here, okay? You have the
Oh,
over 2 here. But just, well, to this problem, this is a really mess because we have the position 0. So
yeah,
the maximum height is 0. This doesn't make sense, right? But
yeah,
this is wrong because you forgot the value of 2 here, over 2 here, okay? So I suppose the maximum height is 11.25 or something, okay? Okay, but okay, you do almost right. B, a position vector instant t, knowing the part of the region, knowing the move starts in the origin of the referential. So, in other words, they wanna equation like this, but to the position, okay, to the position. So, how can I do this for you? You can just look to this. You already do half of the problem. Here is A yet. Here is B. Because the position Y, you have the equation. You already have the equation. You you just use this right now. Is 50 t plus 10 divided by 2 is 5, right? So this is the equation of the position, right? In y-axis, in vertical. The problem wanted this, the position vector of the instant t, the position. The position vector is the two equations, okay? So the first equation is here, and the second equation, you know too, but you need to remember in axis, in your horizontal, you have only the velocity. You don't have acceleration. So the equation is as final. Okay, it's normal put this in this form, s of t, but sy here, or just y. Okay, this is a 5. Okay, and here x dependence t is x0 plus velocity and x times t. But you need to remember the velocity here in x is constant, is a constant, because our velocity in x never change because we don't have acceleration. So again, the position is 0 because we start in the referential of the problem, and the Vx, what's Vx? We have this value in our graph, in the question is 20, okay? The velocity in x-axis is 20. So I will write here 20t. Yeah, so we have the vector. This is a form to write the vector, but I don't know, maybe your teacher prefer something like this. 20t, and we can use this symbol, EX. But this symbol is a trash. I don't like this symbol. It's a trash to me. And here, A, Y. Right? This is the answer of the letter B. I suppose is only this. Yeah. The model of the minimum velocity. I speak to you about this in the final class, in the final of the final class. Okay? The model of the maximum, the minimum velocity. We can understand this problem. Look at draw the graph here. Our move is something like that. Okay, do you remember, I suppose? And we can understand this problem, draw some situations, some positions of our body, and we have velocity in all these situations. But you need to remember, in X is ever the same velocity, always the same velocity. X don't change, again, because we don't have acceleration in this direction, okay? But we have velocity and y-axis. But the velocity is decreasing until the moment the velocity in y is 0. Here is 0. And here we start to falling down. Okay? All these vectors is Vy. So all the situations, you have a sum of the vectors, a combination of the vectors and x, in the vectors and y, in all the positions. Only in these positions we don't have this, in the maximum half again. So you wanna just to know what's the velocity in this position, to know the model, the absolute value of the velocity, okay, the minimum velocity. But I suppose you already understand this. What's the velocity here? Do you know? What's the velocity in this position? Do you know?
0.
What's the value? Do you know?
Of 0.
Okay, in y is 0, but we have a vector here. We have this velocity, this vector here, Vx, okay? All the velocities in horizontal direction is Vx, right? All the same value because, again, we don't have acceleration in this direction. So Vx, the minimum, is equal, Vx is equal 20 meters per second. Okay?
Yeah.
Just like that. Very easy. We don't need to know any math here. Just look to the problem and it's already done. Amazing. Okay, 24 is done. I will save this to send to you, and I will open a new one to do the 25. Man, I need you do some problems alone and bring to me in our class, because we need to try solve your doubts. Because if I do all the things here, it will look like to you, easy, because I know what I am doing.
Yeah.
For me, it's very easy because I work with this a lot of time. But to you, it's not so easy. So you need to know what you don't know. You don't know what you don't know. This is the first thing you need to learn something. You need know what you don't know. It's a little philosophical, but it's the truth. Okay. Let's go to the next one. I will I will translate this with a text to help you. My grammatic in English is a trash, but I suppose you will understand. If you don't understand, just tell me, because I wanna improve my English too. A body is launching um, off the ground with a initial velocity um, where the direction do an angle, an 30 degrees angle with the vertical. You pay attention in this information here with the vertical. The scalar velocity in the maximum height is 10 meters per second. So you need to remember what I just do in the last problem. You say to me, the velocity in the maximum half is 0, and I said, yeah, but only in the y-axis. In the x-axis, in the horizontal, is not 0. It's ever the same velocity, okay? It's constant velocity. Yeah. What is the initial velocity of the body? What, or melhor, which instant the height is 10 meters. Okay, so you have a lot of information here. We have the last problems we do together. We did together. So I will send to you the things we do today, and you need to think a little in this problem. I need to go to the bathroom, so when I come back, you send to me what you did, or say something, ask me something, okay? But you need to think a little, okay?
Yeah.
I come back soon. Hello. Did you do anything?
I don't know how to get the initial velocity.
But you have the angle, you have the velocity in the maximum height. You need to do a draw to understand a graph. I suppose this will help you, like I did in the last problem. Again, do you have this? And you know the velocity here. You know, I just say to you, you know the value of the velocity in x is ever the same. So is 10. But this body have a bidimensional move, so it have a velocity in y2, and you need to know this value because you need to know the velocity, the entire velocity, this velocity here. But again, you have a triangle, you need to use the trigonometric relations, because we want this angle here, theta equals
30.
30, yeah. So what's the triangle we can use here? Tangent again. You close the triangle. You understand this point is equal to Vy. So with this triangle, you think, oh my God, I need what I need here. I need Vy, I need V, the initial velocity. Actually, you need V, the green V, the blue V. I don't know what color is this, but you need this. But we can get this too. But we can focus in the V. But you need to understand the trigonometric functions. You want the hypotenuse, right? You want the hypotenuse. So you can use some equation that have the hypotenuse. If you remember what I write in the problem I sent to you, I write about the trigonometric functions like sine, cosine, and tangent. You can look in the image I sent to you. So if you look there, you have these things, the things here. So we wanna sine or cosine, because if you wanna V, the diagonal velocity, if you wanna this, the diagonal velocity is the hypotenuse. So here we have hypotenuse, here too. So we can solve this with sine or cosine. But what side of the triangle we have? The opposite side or the adjacent side? We have this value here. This is the opposite or the adjacent of that angle? Opposite or adjacent?
Of which one?
Yeah, which one? Opposite or adjacent? This one here. This.
Oh, it's don't know.
Man, I got man. You need to remember, man. Opposite is opposite. It's in the another side, right? The angle is here. Opposite is the another side. We have the adjacent here. Adjacent. Near. Right? So you need to use the cosine. Okay, so you can finish this problem. But to the next class, I need you bring to me doubts. You need to try the another problems. Translate this in Google, something, and try to do, okay? I suppose you have some book in English or in your language to learn these things, but you can download some book, okay? Have a lot of materials, have a lot of books in the internet, so it's easy to obtain one. But you can study this. You can try the problems, okay? The next class, I need you try at least the 26, okay?
Okay.
Okay, so until our next class is in Thursday. So Thursday we try this one, okay?
Yeah.
Okay,
Yeah.
bye bye. See ya.